I'm Sarah, and I just wanted to tell you about a project I've been working on. So just as a recap, TigerBeetle is a financial accounting database designed to store accounts and transactions. It records how much money you have in your account and how that changes as you make payments to other people. Obviously, we can't mess this up. So the team had two problems to solve. Firstly, how can we automatically test TigerBeetle? We're looking for obscure confluences and strange scenarios where things can go awry. We needed a bot that didn't get tired of dreaming up different environments for TigerBeetle to run in, something that could push the limits of our human imagination and patience by thinking through millions of different scenarios. We needed the power of a machine to test our machine. Secondly, once problems are detected, how best can we gather the information needed for us to begin fixing them? That's what I've been working on the last few months. Testing TigerBeetle is tricky because we're not just testing that our database works as it should. TigerBeetle is a distributed database, which means that instead of only having one database, it runs a few copies of itself. We'll call these copies beetles. So we also need to test that all these beetles are communicating properly and that they're storing the exact same information as each other. Imagine we have 3 beetles running in 3 different places in the world. That way, if one of the copies catches fire, the system keeps running and no information is lost. But let's hope it doesn't come to that. The basic idea is that when a payment is made, the leader beetle gets the payment, and before committing it and saving it to disk, it first checks that a majority of the beetles have this payment. Once a majority agree about the transaction, they permanently commit it. All committed payments should be identical across all beetles. We can see everything is working well because all the beetles have the same information. But software is very complicated, and there are always niche cases that are hard to imagine, or small mistakes even the best developers can make. In a system like this, the cost of those mistakes can be very high. Here, for instance, we can see something has gone terribly wrong. Beetle 2 committed a different payment and is no longer identical to the first and third beetles as it should be. Yikes. But instead of despairing, when we see problems like this, believe it or not, we get excited. And that's because TigerBeetle is really running in the matrix. Our matrix is called the VOPR, which stands for the View Stamped Operation Replicator. This is the solution to our first problem. The VOPR automatically and tirelessly tests TigerBeetle under countless different conditions. The VOPR simulates a world with a bunch of beetles. It checks the protocol that these beetles use to elect a leader and agree on what information should be committed. It also tests that each time a beetle is transitioning between states as it commits the next piece of information, that all of those states are correct. The VOPR can simulate network faults that can cause faulty communication among beetles, as well as storage faults that happen when data gets corrupted on a single database. The VOPR does all of this on a single machine, and because everything is a simulation, time can be sped up, and we can fast forward to see what the outcome is in different scenarios. It is a deterministic simulator, which means that with the same starting conditions, the test will run the exact same way every time, which is great because it enables us to track what went wrong step by step. The VOPR is such a powerful testing tool, and a lot of time and love has gone into its creation. So to make the most of it, we have given 4 VOPRs a permanent home. Meet our dedicated VOPR server, which resides in Finland and burns CPU night and day to run 4 VOPRs and uncover any possible bugs that might be hiding away. The VOPRs simulate TigerBeetle, and each time they run, they have randomized environments. So, for instance, TigerBeetle can be run with 3 beetles, or 5 beetles, or just 2. Sometimes we simulate a network so that some messages between beetles don't get delivered. Or other times there might be terrible delays between one beetle sending a message and another receiving it. These VOPRs constantly test the latest TigerBeetle code. But what about our second problem? How do we collect all of that information we need if one of the VOPRs finds a bug? The VOPR server isn't just running VOPRs, it's also running another program called the VOPR Hub that listens out for bug reports. So when a VOPR finds a bug, it creates a report that contains the version of the code where the bug was found, the seed that describes the environmental conditions used to run that test, and the type of bug that was found. It then sends this report to the VOPR Hub. The VOPR Hub is always listening out for new issues. When a report comes in, the VOPR Hub has a dedicated VOPR to use to rerun the test by replicating the exact same environment the test initially failed in. The VOPR Hub collects the debug logs, and if there is a stack trace, it collects that as well. It packages up all this information and automatically creates a GitHub issue that alerts the TigerBeetle team. Here's an example GitHub issue. So far, we've had 16 issues come in, which have enabled some great bug fixes. This makes it easier for the team to follow the logs and dig into the core of the problem and uncover why something went wrong, which allows us to fix it before we release TigerBeetle into the wild. The VOPR hub is always listening, so people can also run the VOPR on their local machine and use the send flag. That way, even when running VOPRs anywhere in the world, they can still submit bug reports to the VOPR hub for processing and issue creation. The VOPR hub also takes care not to submit the same issue twice, so stack traces, seeds, and commits are used to label issues so that when duplicates are found, they're simply logged and not pushed to GitHub. So now we have a pretty cool testing tool and a reporting tool to use on top of that. But don't worry, we have many more plans ahead in the pipeline.